We have to prove that the number of 2 by 2 invertible matrices over ZP is p square minus 1, p square minus p, where p is a prime. Okay. Since P is a prime, we know that ZP is a field. A matrix of a field is invertible if and only if every row is linearly independent vectors. Means no two vectors are dependent. Okay, here we have to show the number of choices of linearly independent columns we get. We have to show that how many choices we have. Okay, how many choices of matrices we have here. Given that it's a 2 by 2 invertible matrix, means linearly independent vectors, and P is a prime. Okay, since P is a prime, any element less than that is not a multiple of it. So it's a 2 by 2 matrix, so we have two rows to consider. In the first row we have no restrictions of other than the 0 being different from 0. If it becomes 0, it becomes linearly dependent. We have to take all the scalars that is not equal to 0, since it is a linearly independent. Okay, so we get totally there is ZP is the field and P is a prime. We have P square chances except the case 0. We have P square minus the term 0 means P square minus 1. Okay, there has P square minus 1 chances. Now taking on the second row. Now looking on the second row, we already fixed the first one. So we have to make sure that that is not a multiple of the first one. Okay, if it become the multiple of first one, it become linearly dependent. But our assumption is that it is linearly independent. So there are exactly p minus 1 linear combination of the first vector. There are p vectors. ZP has p vectors. We have except the case of 0, we have p minus 1 vectors. So with the first row we can make p minus 1 linear combination. So in the second row we have p square minus 1 minus p minus 1 vectors. Can you catch it? We already have p square minus 1 p square minus 1 choices in the first row. So minusing the total linear combination numbers of p minus 1 in the second row, it will be the choices for the second row. Okay, so p square minus 1 minus p minus 1 choices will have in the second row. Okay, in the first row we have p square minus 1 choices. In the second row we have p square minus 1 minus p minus 1 choices. Okay, now opening the bracket and cancelling minus 1 plus 1, then we have p square minus p. So the total chances are p square minus 1 into p square minus p. This is the number of invertible matrix in ZP.